Okay, so we've traveled several more kilometers to the northwest, and we're now looking at an outcrop that, despite that travel distance, is actually remarkably similar to the previous outcrop with the ripple marks. We're collectively within a tectonic zone here that is one or a series of thrust sheets that have been rotated after their initial emplacement. They produce sort of an overall flat-lying effect, so you can travel over the land surface a great distance and not cross any very significant burial depth or even sort of pseudo-metamorphic boundaries. This unit is called the Rome Shale. It's put on maps as a shale. It's really more of a slate, and if you pick up pieces of it and sort of shine them around as they fall apart, you may be able to perceive that this is actually pretty shiny in hand specimen. There is mica growth going on here, and this is more of a slate if you really want to give it a name based on its burial and deformation history. Now, despite this being a slate and very similar to that previous mass that's probably, I guess, 10 or 15 kilometers to the southeast of where we are now, we're standing just above the very significant thrust fault that emplaced this slaty rock mass on top of what we would consider very much sedimentary rock. And if we look just into the distance there, you can see a very prominent ridge on the horizon, and that ridge is supported by Mississippian age sandstone. That's beneath us right now, just a few tens of meters, and where we actually see that rock in outcrop, it is very, very distinct from this material in its burial history, its deformation history, and what you can actually see in hand specimen or outcrop that would communicate those various processes to you. So we'll check that out in the next stop. When it's kind of shiny.